Okay, in the last lecture we have seen how stack can be implemented using array, and today's topic is how the dynamic array can be implemented. Actually, the maximum size of the stack must be defined in our previous lecture, and it cannot be changed. So if the stack is full, if you try to push a new element, but the overflow will be occurred there. So this is the limitation of the previous stack implementation using array. So there is a concept of dynamic array implementation. Dynamic array means every time, suppose one you have defined a stack size of one element will be inserted, and if the second element is coming, overflow will occur. That time the array will be increased by size. Every time when overflow occurs, that is, it can be checked by if the stack is full or not. That I have already told in the last lecture. And after that, it can be increased. The stack size can be increased dynamically. Right. So how do you do this? To try to find out. First try is, suppose every push operation is coming. Initially, the stack size is 1. Initially the stack size is 1. Now every push operation was initially stack size is 1, in that array. Suppose. Now first point is push operation increase size of the stack S by 1, and second point is pop operation decrease size of S by 1. Right. So this is the action. That means just think about the push operation. When some more elements will become, size will be increased by every time. Size will be increased by 1. That means what you will do? Initially stack was 1. How the size will be increased? You have to create another array of size 2, and suppose this is the stack size whose address is 0. Now you have to create a new stack whose size is increased by 1. The address of this is 0 and 1. This is one stack, and this is all the another stack. And then this, suppose this the value is 2 here, then this 2 will be copied to here, then the new element will be inserted here. This will be the new element. Right. And again the third element will be coming, then another array will be created which is of size 3, 0, 1 and 2. Sorry. This is 1 and 2. This is sorry. So here the two elements of this element 3. These two elements will be copied here, 2, and here the 3 will be copied here, and the new element will be coming here. Again, this is the new element will be coming here. So in this procedure, you see after n steps, suppose you want to do the push operations n times, then how many number of operations will be there? You see this. First time it was 1, 1 will be copied to here, then 2 will be copied to here. So 1 plus 2 plus 3 up to plus n. That is basically, you know, this n into n plus 1 by 2 which is belonging to order of n square. This is n square, order of n square. So what is the question? If you want to insert n elements into a stacks, but you don't know the size of n, you don't know the value of n, so how do you create a stack of stack with the help of an array? You don't know the value of n. That means, so this is the procedure how to increase the stack every time. So in this procedure, for doing n push operations, how many, what is the complexity of this dynamic array? That is order of n square. So for every operation, every push operation, for every push operation will take how much time? Order of n square by n, as you want to do the n number of push operations, that is big of n. So the time complexity is big of n for every push operation, but this is actually not desired. It should be order of 1 for every push operation. How it can be implemented? Okay, that's the big challenge. Now I'm going to a new approach for solving this. You see this, where is now new approach is, suppose initially the stack size was 1, suppose. Now stack size will be doubled in the new technique every time. So the stack size will be doubled to the previous size. So here is, suppose it is 2, some elements are there, so it will be copied here and this is created. Now in the second time the size will be of 4, 0, 1, 2, 3. So it will be copied here, this will be copied here, and the new 2 elements, that means if the stack is full here, if the third element will be coming, the size of the stack will be increased by double size. Every time it is doubled. So you see this, suppose you want to insert 32 elements, insert 32 elements into the stack, then how many operations will be there? What is the time complexity of every push operation? Because you have to push 32 elements here. Suppose you have pushed 1 element here now, and the stack of size 1. Now you want to push the second element, you have doubled the size of the array, it is 2, so second element will be copied. Now if the third element is coming, you have to push this. Now again this size will be doubled by 4, the third will be pushed here and fourth element will be pushed here. Now if the fifth element is coming, this size will be doubled, so its size will be 8. It is from 0 to 7, size will be double, so these 4 elements will be copied here, right, and another 4 elements can be pushed here. So in this way you see this in this very first step, 1 element will be copied here. Here how many elements will be copied? 2. Here how many elements will be copied? 4. So when you have created 32 elements, then how many elements will be copied from here? 16 will be here. So what are the total copy operations? 1 plus 2 plus dot 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 up to 16. That is basically 31. And how many push operations are there? 32. Because you see this, every time you are pushing 4 elements, suppose take in this case you are pushing 4 elements here, and after that those 4 elements will be copied here. That means 31 copying operations are there, and push operations how many times? 32 times. So if n is equal to 32, what I am seeing here, it is approximately 2n is the total for doing n push operations. 2n number of operations will be done. So what will be the complexity of every push operation? That is 2. That is basically belonging to order of 1, right? So I want to tell you, I will tell you something here. You see this, um, suppose the number of element is n, then how many elements will be copied and how many elements will be pushed? You can calculate this in this way: 1, then 2, every time it is doubled, plus 4 plus 8. Ultimately you will reach to somewhere where it is n by 4 plus n by 2 plus n. And you see, this n may not be a power of 2, it can be uh, suppose n is 32, then there is no problem. If n is, suppose if n is equal to 28, you can do the calculation for 32, because after 16 your algorithm is always doubling the size of the stack. You double the size, and but you need only the 28 places, because 28 elements you want to push. So take this size always. That means for every number, there is a number greater than which is 2 power of something. So it can be this. So how many? This is equal to, basically you see, if you take this n common, then n into 1 plus, from the back side, 1 by 2 plus 1 by 4 plus dot 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 up to this is lastly it is 1 by n plus here it is 2 by n, like this, right? So you can write this as n this less than equal to n 1 plus half plus 1 by 4. This is a GP series up to infinite. Can I write this? Definitely we can write this. So this is equal to n into, as a GP series, infinite series, and common ratio is half. So it is can you remember the formula? A by 1 minus r. This is the actually a into 1 minus r to the power of n. Here the number of terms is infinite. N tends to infinite, and what is the value of r? R is less than 1. If r is less than 1, it will tend to 0. So ultimately formula will be a by 1 minus r. So here it is 1 by n into 1 by 1 minus half. What is this? This is basically twice n. Is it clear? So twice n is the, if you jump every time the twice than the previous size, then actually you have stopped after log n steps. You see, every time you are doubling this, that means how many number of steps are there? 2 power 1, 2 power 2. After log n step, you will complete, you can complete the your desired number of push operations, and that will need 2n number of, at most 2n number of operations for n pushing. So what is the average time complexity of every push operation? That is 2n by n, that is 2, which is basically a constant. That means it is belonging to order of 1. That means your desired thinking is clear. It can be done in this way. Okay, so it is clear. Now I want to go to next slide. Now we want to discuss the stack implementation through linked list, how it can be done. This is very stack using linked list, right? Stack using linked list. How do you do this? This is the right. Now stack using linked list means I am giving one example here. Suppose all of you are knowing about how to create a linked list, how the linked list is looking like. Now suppose this is the head node and it is pointing to a node here, and suppose this is 3 and this is 150, and this address is 100 and it is pointing to somewhere whose address is 150, and here it is 10 and it is 300 and it is pointing to somewhere, and suppose this is 0 means basically this will go to null, and this address is 300, and suppose the data here is 7, right? So suppose this is the linked list created by you. Now how do you implement stack using the linked list? That means, what is the definition of stack? Stack is basically, there are two operations, insertion and deletion, that is push and pop, and those two operations will be only from one end. That's why it is called stack, only from one end. Either you can push or pop the elements from this head side of the linked list, or you can push or pop from the tail side of the linked list. Now we see this, what is happening if you want to push the elements from the tail into the tail element of what will happen here. As you see in the array is a array. In array, the data are stored in the contiguous memory locations and you can randomly access any memory position, but here you cannot, you do not know the address where it is ending. That means, as it is a linked list, because this node is somewhere else in the main memory, this is somewhere else in the memory this time. So if you want to insert a node, you have to create a node here. First of all, you have to create a node here, and suppose the address of this node is 375 and here the data element is 8, and suppose, and you have to as this is the, you want to push into the tail of the linked list, so it should be null. Now this 375 will be copied here in this 300 location link, but how do you find out this location? You have to search from the head. Head is actually containing the address 100. This 100, it will go to here, go to this link, this again it will go to that address, and from that address you can get the link of the next node. You are getting this node, and now you see this is 0, that means this is the last node. Now you can put this address here, cut it, and you can put this 350. Now it can be. So what is the complexity of one push operation? If you want to push the element into the tail of the linked list, that is order of n, if n is the size of a linked list, you every time. And if you want to, suppose this is the, and this will be cut, and this null will, now this 0 will point to the null address, right? Now if you want to pop this element, very simple, again you have to go to in this way, and every time you have to take care of this two pointers, two variables will be used, and this and this, and as this is null, the previous pointer, it should be 0, then it can be popped, right? So for pop operation, the complexity is again order is n for push operation, and order of n is also for pop operation, but it is not desired, but as we want always the push operation. If the push operation can be done in order upon, then it is good one. Now try to do this with the help of we in the head position. Now what you should do, if you want to do this in head position, then node will be created, this same node, suppose this is 375 and this is 8, and what should be the address if you want to do that. Then you see this, in this position what will be copied, this 100 will be copied here, and head will be, and this 8 will be copied to here, this 100 will be here, right? So that means this 100 address and this 375 address, it would be swapped. This 100 will be stored here first, and then 8 will be copied here. No, sorry. This is basically this is basically 375. Now head will point to directly 375 and it will point to here. What is the complexity? The complexity of this push operation is big of 1 for push. And simply if you want to pop this, go to head. What is the address of then the head link? That means this link will be copied to here directly. This will also take order of 1. That means pop and push operation can only be done at the position head, so that the every push operation will take order of 1 time, or every pop operation will take order of 1 time. That is actually desired, right? This is the concept of stack using linked list. Now I am